Okay, we're going to do a few examples today. Calculating work. And so work is really going to be the dot product of the force vector and the direction vector acting on an object. Okay? So find the work done by a force of 4 pounds acting in the direction of 44 degrees to the horizontal in moving an object 4 feet from 0, 0 to 4, 0. So basically what we've got is we've got this horizontal, right? And we're going from the basically origin, 0, 0, out to 4, 0. Oops, that's terrible. And we have this force of 4 pounds acting at a 44-degree angle. Okay, so when we're doing this, we have to find the force vector, right? And so to find the force vector, we're going to use our formula from a couple days ago. I don't remember. Our magnitude of our force times the cosine of the angle I plus the sine of the angle J. And so when we do that, our force vector is 2.88I plus 2.78J. Yeah, no, that's right. And then to find the work done, okay, we're literally just going to do the dot product of the force vector and the direction vector. Now, your direction vector, guys, your direction vector is literally just 4I plus 0J. All you did was move your object 4 units to the right. So the horizontal movement, remember, the horizontal component of a vector is the I part, and the vertical component of the vector is the J part. So when you do this, you're going to do just the dot product of those two. And remember, when you're doing dot product, you're just multiplying your A's. Remember, the A is attached to the I, so 2.88. So our work is going to equal 2.88 times 4 plus 2.78 times 0. Obviously, oopsies. Obviously, that is going to be 0, but I just wanted to write it out for you. And so your work is going to be 11.52 foot-pounds, okay? Because we moved it 4 feet, and our force was in pounds, okay? A wagon is pulled horizontally by exerting a force of 60 pounds on the handle at an angle of 25 degrees to the horizontal. How much work is done in moving the wagon 50 feet, okay? So we are moving this wagon basically from point A to point B, right? And remember, if we just real quick do that direction vector, we are moving 50I plus 0J because we've just moved along the horizontal. Our force vector is exerting 60 pounds at 25 degrees. So when we go to find this, our magnitude times the cosine of 25 times I plus the sine of 25 times J. And that will be, in decimal form, 54.38I plus 25.36J. And remember, the work is just going to be the dot product of your force vector and your direction vector. And dot product is, of course, just A times A, 54.38 times 50, plus B times B, but of course that second B is a 0, so really it's just going to be 0 there. And so our work is going to be 2,719 foot-pounds. Last one. Person is pulling a freight cart with a force of 41 pounds. How much work is done in moving the cart 20 feet if the cart's handle makes an angle of 30 degrees with the ground? So again, really just the same setup. I ended up we had actually more. If we were in class, we would be doing more, but because we're doing this online, I took out a few of the problems of this unit that they're not terrible, but they're a little more complex. And if we're not in class discussing it and talking it through, it can get kind of involved. So, and you don't need them for calculus. So we just kind of took them out. So 20I plus 0j for that one because we moved it 20 feet, right? Yes. And our force vector, again, we got 41 pounds working at 30 degrees. So that force vector, 41 pounds of force, times the cosine of 30 times I, and sine of 30 times j. And so we get a 35.51 I plus a 20.50 j. And so again, dot product work equals force times the force and the dot product of the force and the distance vector, sorry. And again, because we've got a 0 for that second B, we really just have to do 35.51 times the 20. And so that's 710.2 foot-pounds. The ones that I took off, they have your direction vector. They have it going like not along the horizontal. They have it going like over here, you know, like so you would actually have a component for the vertical as well. So that's really the only ones that we're not doing from this particular little section. But anyway, that's your answer there.